Alright, so this video we're going to cover how to capture a transient waveform. So the big part of capturing a transient waveform is setting your trigger. So right now the scope is in auto mode, and you can see here it's getting a lot of noise. Just somewhere in the system we have some noise. This is what we call the trigger level. You need to make sure that the trigger level is up above the noise rating. Okay, and so you can just on the VirtualBench software, we can just adjust this here. If you're using an actual oscilloscope, there'll be a trigger level knob that you can turn that will adjust your trigger level either above or below. In general, you want it above. So if we come up to trigger, notice the settings for trigger. I'm triggering on channel 1. Usually you'll want to trigger on channel 1 in case, if for some reason you need channel 2, but normally it's channel 1. And you normally want rising. So to capture like a step response, we definitely want to capture on the rising edge. Then we need to make sure that our scope voltage probe attenuation is correct. So if you're using the alligator clip leads, you need to make sure you click on ×1. If you're using the standard scope probes, those are typically ×10, so you need to match. I actually recommend using the alligator clips with a ×1 probe there to reduce the amount of noise. And then you need to set your voltage per division, and right now I'm just doing channel 1, but you could turn on channels 2, 3, or whatever also. And so usually you'll want to have like channel 1 be your input, and then channel 2 will be the voltage across your capacitor, which will be your output. And so once we set this trigger level, then we need to set our timing. So your timing probably will have to be about, for open loop, probably about 500 milliseconds per division up to 1 second. And then we have to set where it captures it at. So by default, it puts this capture point to start capturing at the center. And so this is where it triggers. And so I'll leave this right here for right now. And I've got a slightly different capacitor size, so my voltage is going to be a little bit different. But all we have to do now is click on single, and then we have to energize the system, and we can capture our waveform. So you see here it started triggering right here. If you follow this line down, it triggered once this point right here, you see that little tip there went above that little hump. That's where it started capturing. So that's where the trigger is at. Now we can adjust this by just dragging it along here, or if you're using a regular oscilloscope, there'll be an adjustment point on that as well, that you can have it. You really, when you're trying to capture the step response, you want to be over here near the left side. But watch what happens here. If I have it here at the left and then I switch this up to say 200 milliseconds, now it's shifted that. And so if I put this back at the left and I go back to say 100 milliseconds, I need to change to single mode or whatever, and I can move that. But if I move this trigger here, and now if I click on 200 milliseconds, it goes completely off screen. So if you adjust your time per division, you're going to have to bring your trigger back in here. But in general, when you're trying to capture the step response, you want to have this trigger to be over here close to the left. You also want to have your ground. You don't want your ground in the center, because we want to try to capture as much as possible. So you want your ground set right here at this line. Now again, once we capture it, you can adjust it some, but if you're not at least close, so I can adjust this after the fact, but if I had it all the way here at the center, it would get clipped off, and then I wouldn't be able to use that capture. So we need to make sure that we get it at least close in line here before we trigger our response. Okay, so again, to trigger the response, you just click on single and then inject your signal into the actual circuit, and once that voltage breaks above that this trigger line here, it'll start capturing data. And it actually the digital scopes will actually capture data before that point for a little while. It has it saved in memory on there, but as we adjust it, right, so it only captured it for about maybe 200 milliseconds, just under 200 milliseconds, because my setting is currently 100 milliseconds. Now, as you start adjusting gains on your system, you will have to adjust your times per division, and also probably your volts per division.